It is Friday. It is Friday. It's 6 p.m. here in Berlin. And I assume it is 9 a.m. in Pacific time, a different time this week. Hi, my name is Shudasi. I'm a software engineer, and I've been doing telemetry systems for a while now, since 2015 or so. And since the middle of last year, I'm running this project here called Telemetry Jobs. This is the English-speaking version of the DOS Digitelemetria, a project that I've been running for a few years now. And every Friday or every other Friday, I bring to you half an hour opening session here, and I talk about something about open telemetry. Quite often, I have some guests here with me, both in the English version and in the Portuguese version of that as well. So every couple of weeks, so we alternate. This week is in English, next week is very likely going to be in Portuguese, and then English again. This week, we're going to talk about the Java or the Java performance, or the SDK performance for Java, or performance in general of SDKs. Let's see where the conversation leads us. I invited two of the people that I know that know the most about performance of the OpenTelemetry SDKs. Before I call in my guests here, I have a couple of things to share. So the first one is, for the people in Europe, if you are close to Brussels, if you're close to that area, like if you're in Amsterdam, if you're in Luxembourg, if you're in France, if you're in Germany, we have the Hotel Unplugged happening on the Monday after FOSDEM. So in the beginning of February, so in a few weeks' time, if you are here in the area of, or not here in the area of Amsterdam or Brussels, but there, you are invited. You are invited to Hotel Unplugged. It's an event. It's an unconference, and we invite you all so that we can talk about OpenTelemetry. We can answer your questions. A lot of people from the OpenTelemetry community is going to be there. A few people from the governance committee are going to be there. Quite a few maintainers are going to be there as well. So it's your chance to get answers directly from the people who are building the technology, and it's your chance as well to talk about the cool things that you're doing in your daily job. So if you are close to Amsterdam, or sorry, if you're close to Brussels in the beginning of February, then you can't miss Hotel Unplugged. And the link is going to be here in the show notes. All right, so I'm going to call in then here one of my guests. So I'm going to invite Bruno here to the conversation. Hello. Hey, Bruno, how are you doing, man?
Hi, how are you?
Very good.
Good morning or afternoon, depending where you are tuning in.
Yeah. So, Bruno, would you like to introduce yourself?
Yes, so I'm Bruno Baptista. I work for IBM in the Quarkus team. I'm in charge of the observability tasks and maintaining the extensions related with micrometer and OpenTelemetry. I'm also a conference organizer. I'm one of the organizers of the JNation conference, which the CFP is ending this Sunday. So if you want to submit, please do.
I did not know that. In Coimbra, right?
Yes, in Coimbra,
oh my
Portugal.
God. Nice.
And that's pretty much it.
Cool. Are you coming to Hotel Unplugged?
Yes, I will.
Nice.
I will be there.
Nice, cool. And I'm going to invite now as well Jason. Hey, Jason, how are you doing, man?
Hey, for me, good morning. I know I appreciate you having pushed this back a little bit in Europe so that I could be here not at like 6 a.m. So that's very nice of you. Yeah, I'm Jason Plumb. I'm an engineer at Splunk. I have been working on observability and working on OpenTelemetry for more than 5 years, probably closer to 7 at this point. And yeah, I am a contributor to OpenTelemetry and an approver in OTel Java. I'm a maintainer of OpenTelemetry Android and a maintainer of the newly minted OpenTelemetry Kotlin language project.
Nice.
Yeah, very, very excited to be talking with you about overhead, which is one of my specific interests in this area, and also one that's like very relevant to most users.
Nice. You mentioned 7 years now. Where did you start? Like, I could swear that you've been here for 20 years already, even though the project is only like 10.
I've bounced around in a bunch of different markets, but like this is kind of where I stick now. Yeah, I've worked for a couple of different vendors in the observability space. And yeah, I've been with Splunk for more than 5 years now. Or sorry, no, 5 years. 5 years, yeah.
And Cisco, right? So not Splunk. Cisco.
Yeah, I mean, still Splunk is its own company. We're owned by Cisco, but yeah, they've kept the brand, and there's still, the Splunk products, and they're not going anywhere. And I guess I failed to mention too that I'm on the West Coast. I work remote from Portland, Oregon.
Cool, nice, lovely. And Bruno, you were doing performance work for quite some time as well, right?
Yes. So in the scope of the OpenTelemetry extensions and the monitoring extensions that we have in Quarkus, we decided to set up a performance benchmark setup to benchmark the impact of observability and telemetry in general. Well, it's telemetry. So observability is the end-to-end thing. So you generate data and you visualize and query things. In this case, it's just telemetry because we generate the data that people will later use on observability tools. And yeah, we ended up doing a work that's taken more than a year between setting up, tuning things until we started to get some signals, some data that we thought was valid already.
Got it. So for the people who are watching here, we have a chat function. So you can type your question here, and they are going to answer your questions. But the first question, I'm the one that's gonna ask. Like, the question is, and Jason, this is for you. What is the performance overhead? What is the overhead of OpenTelemetry?
Yeah, that's the question we get the most. My current favorite answer for that question, I think I jokingly told you this the other day, is 13. Just like come up with a number. You ask me the overhead is 13, and then people are like, 13 milliseconds? I'm like, I didn't say milliseconds. Like, what? I don't know. Like, what is so? Yeah, what's the overhead? People often, when they're first getting into observability, they have this app, they have a system that they've built, and they want to observe it. And by adding an agent or adding some telemetry in there, they know that it's going to impact performance, and they want to have an idea in advance of adding instrumentation to understand what that overhead will be, so that they can get ahead of provisioning, so they can manage costs. There's all of the expected reasons why people ask this question. It's not an unreasonable question to ask, but it is maybe a little uneducated. It's a little bit naive. Go ahead.
No, so you mentioned one thing, and I have to make a comment. You mentioned, everybody knows that there is going to be a performance overhead. So there is an assumption that everybody knows that. Although I've seen claims by people selling instrumentation tools, and they're saying no overhead.
Yeah, zero overhead. That's my favorite.
It doesn't produce any telemetry as well, so it doesn't have overhead.
Well, it's like the benchmark for file write operations doing dev null, right? Or So
yeah, I mean,
so let's go back.
I've
Is
also
it
heard
possible?
that.
Yeah.
Go ahead.
Yeah. So the claim was that exactly. So zero overhead, zero code, and zero touch. Basically, like it is nirvana, right? So it is this place where shiny happy people are singing. Like, is that real? Can we get into that situation, or like is that I guess my question is, we are going to talk about the performance overhead for getting useful things out of the telemetry. But is there a situation where it could be even theoretically possible to have a low, or not low, but zero overhead telemetry generation and collection from an application? Is it possible at all?
I think the short answer for me is probably no, but that's oversimplifying the thing. I think you need to sort of define and put words to the definition and have a common understanding of what overhead even is. Certainly, you hear the zero impact, zero overhead stuff by people that are often doing eBPF or OS level, or like even cloud vendor level telemetry, or they're gathering it through those systems. And like even eBPF, right? Like, yeah, you may not be stealing resources from the application itself, but certainly there's resources that are being utilized by the kernel, by the underlying operating system. Like, it's still not free, right? So the application overhead may be less, but certainly your system overhead is non-zero to gather telemetry with eBPF or hardware or whatever.
And I think it's an unrealistic expectation to have zero overhead on something that you must use in production. When you design these production systems, you have to design telemetry. You have to collect data on how the application is behaving. And you know that it's not going to be free, but it's part of the job. It's like security. You know that it's going to take some cycles, but you need to account that in the overall life cycle of the requests and dimension apps and resources accordingly. It's more of an exercise. And I think the important part is that you need to create a setup where you understand for your particular case what's the impact of this. Because it's going to be different for everybody.
We're gonna get deeper into your findings, Bruno. But before going there, and there are questions already here in the chat, right? So what did you compare that with, and where can I find the results, and what is the how is the overhead measured? Those are all good questions. But I have one comment here, and that is, I remember I'm old, sorry, but I remember the days where TLS was expensive. Right, so a lot of the websites would just say no TLS. I mean, we are such a high traffic website that we cannot afford TLS. Like TLS would slow us down so much. Eventually, at some point, TLS even became a CPU instruction, right? So not TLS itself, but the parts of the encryption there, so AES encryption and so on. So then nowadays it's a no-brainer. Like every website out there is probably using TLS. Now I don't have the numbers, but even my stupid blog has a TLS there, and it's a no-brainer. Are we getting there in terms of telemetry as well? Are we there into a situation where the performance might have been bad in the past, but now the benefits justify the overhead? And we don't even have to think, like, is it a no-brainer nowadays, or do we have to be careful? Perhaps Jason.
Yeah, I'm happy to take that one. I think for me, and I'm not doing like high performance computing or anything. I think the answer to that might also depend on what your systems look like. But I think realistically, for most users for the last 2 years or more, I think we've already achieved that. I think the overhead is probably low enough that most users can stomach that enough to at least tune, and then be able to, like, certainly the benefits of observability and having insight into the performance characteristics of your application are like they vastly outnumber the cost of overhead.
Okay.
And we can also like address some of the questions like in terms of like how is overhead measured, because that is relevant to that discussion if we want to go there. But yeah, I think like are we trending toward like more efficient, always efficient, like less impactful instrumentation? Absolutely, yeah. And I think that trend will continue. Yeah, there's always tuning optimization happening in instrumentation.
Which is a good point to have. Like, it is not perfect yet, right? So we do have room for improvement. We're not done. Or you are not done. Like, you both are not done. I know some of the work that has been done in Go, for instance, since October last year. The performance of the Go SDK has improved a lot. So if you haven't tried the Go SDK since October, then give it another try. The way that things work. And specifically, one of the concerns that people have, like, oh, the counters had mutexes in the past, like they don't anymore, right? So if you hear that argument, just say it's not the reality anymore, like it's fixed. So the performance, the number that I heard was it is 60% better, like compared to the previous version. So how do they compare previous versions? And then, so let's get into the methodologies there. So Bruno, can you guide us through like what was your work and what you've done and how you did it?
Yes. So the idea was to measure the performance of an application, real world application, more on that later, of a real world application under high load, and see what happens. So when the application starts to break down, so we start to get errors, we back off a bit, and we take measurements at the constant bit request rate. And then we do measurement for the first request, because usually it takes longer than the other ones, and we want to understand how much is that. And then we warm up the JVM for, I don't know, 5 minutes, something like that, where we increase the rate, the request rate, until the nominal rate that we define for the test. So it gives time to all the code to be compiled, and everything is warmed. So when we collect the results, we don't have any compilation funkiness. We just get the normal allocations and garbage collection that the application is doing. And yeah, and then we measure. We measure the application without observability, with metrics, and then metrics plus tracing. And then in our case, because it's Quarkus, we do this for the extensions. And then we do a separated measurement for the OpenTelemetry agent working with Quarkus. And yep, that's what we do. But there are many things in between, because the machines that we use are dedicated machines. So we allocate a fixed number of process of CPUs to the Java process that is running the tests. So usually we stick with the 2, which is the minimum. So the less resources you give, the sooner you will start to see problems happening. So that's what we do. We start with low memory, like 1 GB of a heap, and we see what happens. And we tune the machines, the operating system. So let me get some notes, because that's kind of a thing that we need to do. So we reduced the number of running processes to the bare minimum. We disable CPU power management, and we use only local and private networks, so to have minimal impact of I/O. And we also optimize the TCP buffers, and we balance the interruptions between all the cores. So the idea is that between runs, we want to minimize the variance of the results. And even like that, we have a lot of variance. Even in a curated environment, that happens. So for the measurements, we take 3 different measurements and average them. But I'm now convinced that that's not the right way to do it. So in the future, we will use some other methodology to
Why?
do this. Because these results, they don't follow a normal distribution. So averaging them doesn't mean much. We are going to start doing it in a different way, and because we need to do multiple runs to basically reduce the variance of the results.
Okay, so I have one question there. So can you get to the results? Like, I guess the question is, why am I so eager to see the results? Like, if you turn off all the things that can cause a variance to the results during the benchmark, and the real world does not have those things disabled, does that mean that the variance is so, does it mean that the results, they are so close to each other that once all of the variances are enabled, they are going, you can see the difference, right? You see what I mean?
So one thing is seeing the effects. The other is running an application in production. So what I now call a production application is an application that hasn't been optimized. Because most factors that bound the performance on a real-world application are not related with the telemetry. So you will get poor performance because, I don't know, you have bad queries here and there, or you have more sessions that you should, and you are over-allocating for some reason. And because all of that, even if you are doing a crazy amount of telemetry, it doesn't impact much because all the other factors are dominant. You see, that's why I'm always very careful and don't like to show the particular results, because those results, every performance result that you see everywhere in the world, are because of a set of conditions that led to it. They are not generic. They cannot be extrapolated for your case. And that's a painful thing. Usually people want to have a quick answer and see a slide. Oh, that's 30% overhead on performance. And it doesn't work like that. It's 30% on that case, on that run, for that environment, for that application running that type of load. With that memory, those CPUs, if you change something, you'll get different results.
That's a huge takeaway. I can't emphasize that enough. I agree 100%. And it's really important that users hear that and that they understand it, that overhead results from one application is only overhead results from one application, and yours will be different, and you have to test it yourself to understand it. And when you test it, you have to understand what your load looks like what a production load, what production inputs look like, what your error rate is, like all of that is relevant.
Yeah. So the important part of performance tests, it's not picking them from the internet, from some case that you don't control. The important part of performance tests is you have to do it yourself for your application, because when you get them and you profile your application, will allow you to understand what the bottlenecks are. Performance test is not to say, oh, use that library, you will get improvement X, or yeah, you will get eventually an improvement if conditions are fairly similar. But the important part of performance tests is for you to understand how your application behaves and how can you improve it. So from run to run, you can, so one run, you do some improvements because you profiled it and you found, oh, we are using this hash map. We don't need it. We can do it from in a different way. And suddenly you have more performance because of that. And then you can compare, okay, so this change improved me 20%. And that's fair, and it applies to you, but it's just for you. And most performance tests are like that.
So I remember somebody very smart that I watched a presentation in Paris last year. So he had a presentation called How to Think About Instrumentation Overhead. And that was you, Jason. So the link is here. I think that people on LinkedIn are not going to see it. So people who are on YouTube are going to see the link. But if you go to YouTube and type in like Jason Plumb and KubeCon or overhead, I don't know, you're going to find this video there. And one of the takeaways that I remember, Jason, is something that I also heard during an outreach internship from the Open Tracing Days. So during the Open Tracing Days, we've done an internship with Gabi Soria, and she ran a few experiments with Open Tracing alone, like no instrumentation, then Open Tracing with a no-op, a tracer, I think that was the terminology back then, and then Jaeger. And the results that she found out is one of the things that you also mentioned. Like if your application is doing anything that is meaningful, like it is making an API call, talking to a database or message or whatever, that is your bottleneck, not your instrumentation. Like, of course, there might be situations where your instrumentation is really doing something funky, but it's so rare that typically your bottleneck is not going to be that. And just while you're talking, Bruno, I thought about one specific trace that I saw during my Monday to Thursday job, which was I was preparing a report to a user of Garden, and one of the things that I saw on their telemetry was an N+1 kind of situation. Like we detected a N+1. Of course, we are not in the business of telling people what their services are doing. We are in the business. Well, we're in the Garden head. So that's Monday to Thursday, not Fridays. So Oligarden is in the business of showing people how good and how bad their telemetry is. And if there is a span that is repeated within other spans, that's a bad pattern, right? But that typically reflects what the application is doing in that particular case. So N+1s, they're bad typically, right? So if you are doing N+1, why are you caring about the overhead of your instrumentation? Good. So we went there. Do you have a number at least, like 13? So you mentioned 30, but then Jason said 13 at the beginning. Like, what is a good baseline to have? Like, how should I? What is normal? I remember back in the open tracing days, we had a number. We said like 15, so very close to 13 from Jason. We said 15 is typically what is acceptable in whatever is your bottleneck. If you care about memory, then 15.
15
exactly. So
yeah.
The units would vary based on what is important to you. Like if it is memory, then 15% memory could be okay. Like 15% CPU or network is typically not the case. But if you care about CPU, then, which is typically what people care when they talk about instrumentation, then 15 is a good number to think about. But those were like 2017, 2018, right? So what is the baseline today? Like what is normal and what is not normal?
Well, I can tell you that usually I don't care much about the CPU and memory, because the application will run efficiently enough. I care about response times, and I care about the percentiles of the response times. And eventually, if you run out of memory,
just to jump in, Bruno, like that, even just mentioning percentiles is something that people often overlook, and they just look at median response latency, and that's never enough, right? You do need to look at your distribution. You will not just have one response time. This is something I bang on in my talk a little bit, is like, you have to look at your percentiles, and just looking at median is not enough.
Yeah, let me show you just an example. Let me try to find the slide. So these are percentiles. So the 50th percentile here, the 90th, and until the 99.99. So 100 is the request that took longer, and all the rest of the requests are below. So in this case, 50% of the requests are here. They are below 1 millisecond. So all this is in milliseconds. The different colors are so a run with micrometer, with metrics and tracing in red. Off is no observability at all, and the OpenTelemetry agent here. So, and in this case, the telemetry overhead here, well, it's not much, especially because the scale is logarithmic. So if we calculate the percentages, you will get what you like, which is a value of the percentage. But the percentage is different depending on the percentile. So if you see the median, the 50th percentile, and median and the 50th percentile are the ones that are important, because again, this is not a Gaussian distribution. This is an exponential one, as you can see here. So average is worthless. So the median is the one that you should look about. And in this case, metrics have not even 3% overhead for the 50th percentile. And tracing will have a 20% overhead. But if you do it with the agent, it has a bit more. But as the applications start to struggle, so the requests that take longer, that difference, that impact is larger. And this application is already struggling. So usually we want low values on higher percentiles. Remember that So if you have the 99th percentile, it means that 1 in 100 will have this overhead. So we are seeing, let's say, 10 seconds to, in the case of the agent, 10 milliseconds to around 100. And that might impact, that might not seem much, but I don't know. Even if you load the Google page, the one that just said Google, I think it makes 60 requests or something like that, which is crazy. And and so 1 in 100, suddenly it's not that uncommon. So and it will slow down loading of all your requests, all your pages very quickly. So that's why the percentiles are important. So we want higher percentiles depending on your the quality that you want. But well, you can pick this like that. But again, this is for this particular throughput for this particular application. It doesn't mean in your case will be the same. And this application was streamlined and optimized to the maximum to highlight the performance, the telemetry impact. So if your application has poor performance, you will not be able to measure any of this because it will not float. So basically, what will happen when you do a run? You do the next run, it's completely different, so you cannot infer any results from it. There will be a very high variance. And some crazy things might happen, like if you add observability, things will get faster. It's true. It happened to me while I was developing this because of the way scheduling and threads and block themselves and things like that. So all kinds of crazy things might happen, and you will not be measuring what you think you are measuring.
Yes, I remember getting into a very strange place when doing performance benchmarks for Hibernate. So when I was at Red Hat back then, in I don't know, a lot of years ago, I was in charge of doing Hibernate quality assurance engineering, and one of the things that I've done was trying to measure the performance overhead of Hibernate itself, and it's so hard. Of course, we see that there is an overhead there. I mean, I can feel that direct JDBC for good queries are good, but one of the things that we end up finding was not every developer can write good queries, and for sometimes or quite often, Hibernate can actually write have good hints, so it can write good queries for the databases for specific dialects. Like it can make good decisions. So Hibernate versus, I would say, like a bad developer, Hibernate beats them, right? So it's very hard to say that ORMs are bad per se. Like it really depends on the situation, the gains that you gain, like the productivity gains that you have as well. And I think the same here, right? Of course, we're not measuring productivity gains, but we're measuring like, am I able, when I don't have any caffeine in my veins at 2 a.m. in the morning, when my application is down and when my phone rang, do I have telemetry to tell me what's going on? Like, do I care about the performance overhead of my application then? Probably not that much, right? I mean, I prefer to have observability than to have a zero overhead.
And even for people that are super concerned about the performance impact, what I can say is that at least metrics, they are fairly harmless. Mm-hmm. So if you running a performance application, you don't have metrics, well, you should. Probably you should. Because performance is not an issue. Unless you do bad metrics that will explode the cardinality and blow up your memory, but you need to know what you are doing. And for tracing, even if it has a higher impact, there's always mitigation that you can apply. So you shouldn't be sampling all the requests. So on the results that you saw that you guys saw before, we were sampling just 10%, which you say, oh, but what if an error happens and I don't sample it? Well, it's after a week or two, you will get the sample of most things. So
yeah, let's be clear. With tracing turned on, like you were pushing 7,500 requests a second, and so at 10%, you're still getting 750 traces per second. Like, yeah, so
yes,
that's still a lot of data. Like 1% might have been even enough for you. So
yes, most likely, yeah.
I wanted to respond to a couple of things, just to emphasize again that when you're doing your testing, you want to stay out of those chaotic zones. Like you don't want to have your CPU pegged. I think Bruno touched on this. You want to give yourself some memory headroom. Like generating telemetry is going to use some amount of like baseline memory. And if you're already kind of hitting garbage collection in Java, at least when you're hitting like garbage collection problem world, that's not when you want to do your test. You will get inconsistent results and they will be hard to predict. So you want to do these measurements like when you've got some clear headroom for yourself. The other thing I like, the main takeaway from my talk and like the stuff I want to bang on the most is that people love to classify overhead as a percentage change to latency, right? So if you have an API or a service that responds in X milliseconds, let's call it 100 milliseconds, and you add the agent and you're like, oh, now my latency used to be average 100 milliseconds and now it's average 125. I can do math, like that's a 25% increase in response latency. And the reason why that talk and the reason why that white paper that started all this is called How to Think About Instrumentation Overhead is because I think that's the wrong way to think about it. And primarily it's an algebraic problem in that you can't just take that difference and compute a percentage, because of what we said earlier, you don't just have one latency, there's a distribution. But also the baseline, like you're in the example I gave, there's a baseline app with 100 millisecond response time. Not every app has that, right? And if the overhead is essentially a fixed cost, which it is, right? Like with some variance, okay, it's not fixed, but it's like a constrained cost, overhead cost for the telemetry, for instrumentation, then what you're comparing it to, the percentage that you're computing is on an app versus an app that does this versus an app that does this, right? And those are going to have very different characteristics for the same instrumentation overhead, right? Whatever that cost of instrumentation is should be a small fraction of whatever your app does, unless your app does nothing, right? If your app responds in a couple dozen microseconds, right? Well, then the instrumentation overhead is going to appear percentage-wise to be huge, even though it might only be a couple of milliseconds. If you're down in like the super low latency, then yeah. So I think one of the things I say in the talk is that like using percentage latency change as a measurement or a qualification of overhead is kind of misleading, and you should be very careful when you classify overhead as that. Yeah.
Yep. That's wonderful. I have two more questions. I know we are almost at time, I think, but I do. Okay. It's so interesting. I do have, and people, if you have questions, write here in the chat, right? So it's your chance. So the two questions. Let's see. The first one is, what were Bruno, perhaps? What were the outcomes of your research there? Like, what are the things that you could bring to the community to improve the things that are being under measurement? I see one comment here in the chat. I don't know if it's connected, but one of the comments here in the chat is the Java SDK implemented zero memory allocations, which became the default memory mode about a year ago. Like I could see that being one of the outcomes of potential benchmarks, perhaps not this particular benchmark, but what are the outcomes of this benchmark? Like
So for starters, I fixed probably 4 or 5 bugs in Quarkus because of this. Which is the whole point of doing performance testing. So we found bottlenecks and we removed them when we were using the OpenTelemetry extension. And we found out that for the agent, for example, if you have small heaps, which nowadays is less than, let's say, 8 gigabytes, it's probably better if you run your application with the agent using parallel garbage collection instead of G1. because the cost of scanning the whole memory is less than having G1 managing the different regions. So G1 is optimized for latency consistency, and the parallel is optimized for throughput. So if you want more throughput, probably you need to pay attention to your garbage collector, so you can squeeze more performance from your app when you are using the agent. And that's quite that has quite an impact. So it's something that is day from night if you change the garbage collection at this high rate throughputs that we were measuring. Yeah, though those are kind of the most important parts that we found from our work.
Okay.
I want to make one quick clarification to the comment about zero allocations. I'm an approver over there, so I kind of know I know the way that went down. And just to clarify, it's not zero, but it is low. So there's no guarantee that it's zero allocations, but it's especially on the exporter. It's the marshalling side of the exporters, and those used to allocate all the time, and they were pretty high memory usage. And those have been they are the default now, the low allocation marshalers for the exporters.
Okay. Cool. So I have so many more questions. I wanted to make sure that we covered all of them. So what did you compare? I think we covered that one. So this is where can I find these benchmark results? Did you publish that already, Bruno? I thought you would be publishing. I think you had a presentation during the SIG call this week or last week.
Yes. So in my case, I want to publish something on a blog post, but I still want to do more work. So I did a few conferences with this talk, and I will also go to the Unplugged conference. And well, it's an unconference. Let's see if people want to see the results. Let's see. But for now, we just have the slides. We don't have kind of a proper article where people can look at them.
But Jurasi, how can people find the SIG call recordings?
Oh, yes.
Ask Claude, ask Gemini, ask ChatGPT. Yeah. I don't know.
Yeah, people can find the OpenTelemetry Java calls, but I also have the code is open source. So let me share the link here. Let me share the screen.
And remember, with these benchmark results, this is one app and one test environment, and your mileage will vary.
Oh yeah,
it's super helpful to have this stuff, but remember, just keep it in check.
Yeah. So this link here has the code for the Java application, and it also has a guide on how to run it yourself if you want. Most likely you will get errors because you need a beefy machine to run this with the throughput that we have there, but you can reduce it. But you will get the picture on how these things work.
Cool. If you could send me the link, because I'm on an XKCD comic right now because I cannot scan the QR code because I'm on my machine. But if you could send me that, then I can post here in the chat. I also posted here in the chat the link from Jason's work on this in this area as well, so you can find the results of Jason's the findings there in this PDF here. Again, if you are on LinkedIn, you're probably not seeing the links. If you are on YouTube, you are probably seeing those links. If you cannot find them anywhere, ping me. I'm on Slack. I'm on LinkedIn. I'm on, I don't know, in other places. Find me and I can share those links with you. I have one more question, final question. And it is, so I guess the takeaway for me right now is, so I should not care about instrumentation overhead so much, especially if my application is doing something important, or something meaningful, or the overhead is very likely going to be low enough. If it is not, if I'm being a good boy. I'm providing my application production so I can see where things are going. And then when I find a problem, I can go there and fix. Good. Now, what are the cases that I know already that instrumentation overhead is a no-go? Are there situations like gaming consoles, cars, airplanes? Like, is there any kind of situation, real-time systems? Like, is there a situation where that you would say you should not instrument your applications, not open telemetry, not anything at all? Like, this is not the case for telemetry collection at all. Are there cases like that?
I mean, there are bound to be. I mentioned high performance computing before. I mean, if you are really pushing the boundaries of what computers can do in terms of throughput, then I think adding anything in the critical path is kind of a showstopper. But then you've got a chicken and the egg problem. Is like, how do you know your throughput if you're not measuring it? Like, how do you know your performance if you're not measuring it? So there is this strange interaction that happens between the thing doing the measurement and then the thing itself.
Yeah, it's the Schrodinger's cat all over the place.
Yeah. I studied electronics, and I learned pretty early in college that when you put a oscilloscope probe into a circuit, you're also changing the capacitance of that circuit, and that's a lesson you have to sort of learn. And if you don't realize that, you can really interpret your results the wrong way.
That's Heisenberg's, isn't it?
Yeah, Heisenberg. Yeah.
So that's something that I also learned during the quality assurance at Red Hat back then. Like, the single fact of observing something changes the outcome. So when you are trying to find a bug and you cannot find a bug, that's a Heisenbug. So that we have a name for that. So that's the Heisenbug. It's the bug that you know it's there. Like, you're seeing the logs, you're seeing like the things. But then when you start profiling the application, you don't find it. Or when you start adding more telemetry, you don't find it. Cool. So that's there. So I think I'm happy. I'm so happy because I learned a lot today. I think I have a few takeaways. So I mentioned one already, that I should not be overthinking instrumentation. Like, it is the value that it provides is way higher than the costs. I think this is one thing. The second thing is, and I think we might have touched, but not explicitly. There is a lot of value in doing those exercises, in doing the benchmarks. Like, even though we know from like multiple tests, multiple experiences, that the overhead is not. It is not that it's not important, but there are other things in your application that are causing the bottleneck. I think that there's still a lot of value in doing the benchmarks. We learned so much about the tooling that we are using there. Like, you fix bugs in Quarkus, and you probably share the results with the Java SDK folks from OpenTelemetry, so they can fix some of the things, the things that you might have found there. The same with Go. Like, benchmarks run with Go caused all of the performance improvements that were made since October. And I believe that we are starting to do some benchmarking for the collector as well, like OpenTelemetry collector, so I can see some improvements going there. So that's another takeaway that I get is there's a lot of value in doing those benchmarks. Final words, Bruno.
Yes. So we talked a lot, but well, there's plenty of things that we didn't mention, like load generators and things like that, and all the things that are wrong with them. But I think we mentioned some key points, and I think that the most important is that you should see performance tests and performance results with some degree of skepticism, and think on your own if that applies to you, and what was the methodology that was used. And it's an interesting work. So we see some performance test, and can you spot if you have all the data to properly understand how it was made? If you don't, probably the result is not valuable for you. I think that's the main key. Independently of the overhead that things might have, is that you need to do your tests yourself for your case.
Yep.
Jason?
Yeah, I'll plus one that. I think, this is a very complicated topic. There's a lot of variables. There's a lot of parameters, and constraining all of those and then interpreting the results is actually very complicated. And your best bet is to measure it yourself and to take the time to understand how your applications perform. And sometimes, most times, I think you just sort of are able to eat the cost. Maybe you tune a couple of parameters, like your memory usage, like your heap size allocation, and then you tune your sampling, and you're good to go for a lot of people. But much like the most secure computer is the one that's encased in concrete and buried underground, and turned off, that's the most secure computer. If you want to reduce your overhead to zero, just turn off all traffic at the firewall. If your app's not doing anything, you're going to get no overhead. So there's different ways of optimizing, right?
Yeah, but one thing that you both mentioned is you should measure your own things, and that reminds me of the biggest truth in benchmarking, which is I don't trust the benchmarks that I didn't fake myself, right? So yeah, and with that, I think thank you, Jason. Thank you, Bruno. Thank you very, very much for this conversation here. I enjoyed a lot. This is such an interesting topic. And I would like to close this one here today with another call for participation for OTel Unplugged. We have the CFP is open until the event, so it's an unconference, so you just go there, you propose, and you show up and you present. If you liked what you've seen here, people who are watching, then hit the thumbs up button. Carla always reminds me to do that, because apparently if you do that, things get better, and people with the same interest, they receive recommendations for it. I don't know. I just hit the button there. If you are on LinkedIn, we have a LinkedIn page where we share a few things a couple of times a week. And on YouTube, we come here once a week on Fridays, and we open those live streams. Bruno, Jason, thank you very much, and see you around in the community and perhaps in person soon.
Thanks, and have a nice weekend.
Yeah, thanks for having us. Appreciate it. Take care.